Okay, today we're going to continue talking about confidence intervals, and we're going to look at confidence intervals for different of proportions. So when our data comes from our two random samples, so again we're looking at that random condition here, two random samples, or two groups in a randomized experiment. The statistic p hat 1 minus p hat 2 is our best guess for the value of p1 minus p2. So our sample proportions being subtracted is going to be our best guess for the true proportions, for the population proportions. We can use our familiar formula to calculate the confidence interval for p1 minus p2, which is the statistic p hat 1 minus p hat 2, plus or minus the critical value. So this is our z-score value based on our confidence level, times the standard deviation of the statistic. Keeping in mind that our new standard deviation formula is a standard deviation of combining the two distributions p hat 1 and p hat 2. And so again, because this is based on our sample data, it's going to be called our standard error instead of standard deviation. So just kind of the layout of how this should look for your problems. The two sample z-interval for a difference between two proportions. Our state part, we're going to go ahead and estimate the difference in the proportion of blank and blank with usually 95% confidence, but sometimes 90%, 99%. We're going to use the two sample z-interval for proportions if our conditions are met. So we've got the conditions, the random condition. So our data comes from a random sample. Both sets come from random samples, or two groups are set up in a randomized experiment. We have to check the normal condition, and we have to check it for each set. So the n1 times p1 is greater than or equal to 10. The n1 times 1 minus p1 greater than or equal to 10, n2, so on and so forth. Really just looking to see if the successes and failures in each sample are at least 10. And then, of course, we have our independence condition, where both samples or groups themselves and the observations are independent. So the groups should not be affecting each other, and then the observations should not be affecting each other, or they both meet the 10% condition. And you have to check both groups for the 10% condition. Now, if those conditions are met, then we are moving on to performing our calculation. So then we actually calculate our p hat 1, p hat 2, and then we calculate the difference between them. Then we go into our z value, so our z star, the critical value that we get from our inverse norm. And so we do 1 minus our confidence level and then divide by 2. So 1 minus 0.90 and then divide by 2, so 0.05 would be that. We also have some other options to us that we can use for this, and that could be using table A. So we could look it up in table A. Or we could go to, sorry about that, we can go to table B. Which is our t-table, but what's nice about the t-table is it has that infinity line at the bottom, and then we can actually look up that z-star value. So there's other options to us. This one's nice because if you don't have a very good calculator or you couldn't remember how to do it, you could always look it up in table B. And then we go ahead and we calculate our interval. So then we calculate the statistic, the subtraction, plus or minus our z-star times the standard error, remembering that this is our margin of error. Wow, I'm not writing very well today. And then this is our standard error instead of standard deviation. And then we interpret the results. We are 90% confident that the interval from blank to blank captures the true difference in proportion of blank and the proportion of blank that blank blank. So again, just looking at what do these numbers mean? What do they mean in context of the problem? Because really we have to understand what's going on in the situation. So now we're going to go ahead and we're going to look at a sample problem. Are teens or adults more likely to go online daily? The Pew Internet and American Life Project asked a random sample of 800 teens. So let me grab my highlighter here so we can highlight that. So 800 teens and a separate random sample of 2,253 adults. So one of the reasons why there's more adults is that it's easier to sample adults than it is teens, because teens, legally, you have to get parental permission to be able to actually survey a teen. So now in these two surveys, 63% of teens and then 68% of adults said that they go online every day. Construct and interpret a 90% confidence interval for P1 minus P2. So our state part, we're going to estimate the difference in the proportion of teens, P1, and adults, P2, that go online every day with 90% confidence. We're going to use a 2-sample z-interval for proportions, and we're going to check our conditions. So random, yes, we have an SRS of 800 teens. That's not working very well. And we also have an SRS of 2,253 adults. Oops. Normal. Okay, so now we have to check and see if it's normal. So now we're going to do, okay, 0.63 times 800. And so we're going to go ahead and calculate that. Okay, so 0.63 times 800 is 504, which is definitely greater than or equal to 10. And then we take the remainder. So let's see, we have 0.63, so we have 0.37 times 800, which gives us 296. So that is greater than or equal to 10. And then we have to check the other sample. So 0.68 times 2,253 gives us not an even number, 1,532.04, which is okay because it's still greater than or equal to 10. And then we have the 0.32 times 2,253, which gives us 720.96, which is greater than or equal to 10. So both of them work for us, giving us that we've met our normal condition. So now independent. Well, it is reasonable to assume that there's more than 8,000 teens. And reasonable to assume that there's more than 22,530 adults. And it looks like it was an American Life project, so probably in the US. Easy to say, easy to assume. So now we're going to go ahead and calculate our different parts. So the first thing we're going to do is calculate, well, we already know p hat 1 and p hat 2. So we're going to do our z star, which is going to be an inverse norm. And then if it's a 90% confidence interval, we're going to take that remaining 10% and divide in half for the two tails of our distribution. So this should be area of 0.05. And because it's a z-score, it's going to have a mean of 0, a standard deviation of 1. And this will give us our z star value, which is 1.645. So now that we have that with my horrible writing with this little stylus, that's okay because it's close enough. So we're going to do p hat 1, so our teens, 0.63, minus p hat 2, which is adults, 0.68. And then we're going to plus or minus our z star, so 1.645. Fix that. 4, 5. And then we're going to times by that standard deviation, which is 0.63 times 0.37 divided by 800. And then we're going to take that 0.68 times 0.32 all over the sample size of 2,253, which is going to give us negative 0.05 and plus or minus 1.645 times our standard deviation. My paths are looking really weird today, which is 0.0197. Okay, so now we're going to figure out that 1.645 times 0.0197, which gives us negative 0.05 plus or minus a 0.0324. And so now this is going to give us an interval of, so I'm going to take the negative 0.05 and I am going to subtract that 0.0324, which is going to give me a negative 0.0824. And then I'm going to take that negative 0.05 and I'm going to add the 0.0324, which gives me an upper negative 0.0176. And now I have my interval. So we are 90% confident that the interval from negative 0.08 to negative 0.02 captures the true difference in the proportion of teens and the proportion of adults that go online every day. And so then we'd want to start taking a look at, well, what does this tell us? Does it tell us that they go online about evenly or not? So for it to be even, for the difference to be even, 0 would have to lie in here. And since both values are negative, 0 does not lie in here, which means that teens, based on this, go online less than adults. And so then you may want to start looking into other studies on the possible reasoning why teens would go online less than adults. Now, this sample was from way long ago, probably about 6 or 7 years ago, so data may be different now. And so these are all things that we can look at now that we've run this test. Now what do we do with it? Okay, so now the next step in this chapter is to go ahead and start doing significance tests. So what's the likelihood of getting results like this?